Hello all! In late 2025, an international research team led by Paderborn University in Germany was the first to teleport quantum information between photons produced by separate quantum dots, making quantum repeaters and a quantum internet more feasible. What exactly does this mean? So quantum dots are semiconductor nanocrystals that behave like artificial atoms. They can emit individual photons on demand and briefly store quantum information. In the quantum information teleportation, the photons had to match in color, timing, and shape, a task that required previous years of materials science development and precision quantum dot chip design. To carry the photons over standard fiber optic cables, physicists employed quantum frequency converters, shifting the photons to telecom wavelengths without disturbing their quantum state. One quantum dot emitted a single photon, while a second quantum dot emitted an entangled pair of photons. When the single photon interacted with one of the entangled pair, its quantum state transferred to the third photon, even though those two photons never physically met. Sound confusing? Here's the breakdown. There are three photons. Photon A, the input photon, is the one whose quantum state is teleported. Photon B, the output photon, is one half of an entangled pair of photons, located at a remote output station. And photon C is the other half of that entangled pair of photons. Photon C is physically sent to photon A, so only photon A and photon C physically meet. But the output photon, the one that acquired the quantum state of photon A, is photon B. Photon A and photon C are absorbed during the experiments. The physicists measured the fidelity, which is the accuracy with which the output photon, photon B, reproduced the quantum state of the input photon, photon A. In one set of the experiments, the physicists used a 10-meter, or about 33-foot, fiber link, and the post-selected teleportation fidelity maximum was about 72%. In another set of the experiments, they used a 270-meter, or about 886-foot free space, or open-air, link, and the post-selected teleportation fidelity maximum was about 82%. Both results are clear confirmations of true quantum teleportation. Note that classical methods, aka non-quantum entanglement methods, only achieve a fidelity of about 66%. So why does this matter? A quantum internet could link distant quantum computers to operate as a single supercomputer, be virtually immune to eavesdropping, and enable new types of sensors for navigation, medicine, and climate monitoring. So the age of a quantum internet is no longer just theoretical, it's actually materializing, photon by photon.